Hi everyone, in this video we will solve the LeetCode problem number of steps to reduce a number in binary representation to 1. We are given a binary representation of an integer as a string s, and we need to return the number of steps to reduce it to 1 under the following rules. If the current number is even, we need to divide it by 2, and if the current number is odd, then we need to add 1 to it. And it is guaranteed that we will always reach 1 for all test cases. So the problem is we are given a binary string. If the number is even, we divide it by 2. And if the number is odd, we add 1 to it. And we repeat this operation until the value becomes exactly 1. And our task is to count how many steps this process takes. A naive idea is to convert the binary string into an integer and then simulate the process step by step. But that will not work here because the binary string can be very long. As you can see, the string length can be up to 500 letters. And that may not fit into a standard numeric data type. So instead of working with the number itself, we will work directly with the binary representation. And here is the key observation. The task of making a number equal to 1 is equivalent to removing the n minus 1 last bit from the string, as the most significant bit is always 1. For example, if we have a number like 10 and we need to remove the n minus 1 last bit from that string to keep the most significant one. So we need to remove all of these 3 bits to keep the most significant one as a result. So how to do that? In this number 10, it is an even number. Then the allowed operation here is to divide by 2. And this division will remove the least significant bit. If we divide 10 by 2, it will be 5. Then this number is odd. And again, to remove the last bit, we need to do 2 operations in this time. The first one is to add 1, and that will give us the binary representation of number 6. So it become even again. Then we need to divide again by 2. And that will give us the number 3. And as you can see, when the number is even, we need just single step, 1 step to remove the least significant bit. And when the number is odd, we need 2 operations. First add 1 and then divide by 2. So we need 2 steps when the number is odd to remove the least significant bit. So the conclusion here is every even number needs exactly one step, and every odd number needs 2 steps. But there is something that you have to take into consideration, which is when we have an odd number and we add 1 to that number, it may create a carry that affect the next bit. Like this case, when we add 1 here, the second bit is modified to 1 because we have a carry in this case. So all we really need to track is one thing, whether a carry exists or not. And now let's move to the code. We start by initializing 2 variables, one to count the number of steps and another to keep track of the carry. Now we loop from the end of the string towards the beginning, but we stop before the first bit. Why we need to skip the first bit? We need to stop the loop before reaching the most significant bit, because once we are there, the number is already very close to 1. So as you can see, start from right to left, and I is greater than 0, not greater than or equal to 0, because we need to skip the most significant bit. At this step, at each step, we will calculate the current bit value by adding the carry to the bit in the string. So let's define a variable called bit equal to the current character or current bit in the string. Let's convert it to integer and add the carry to it. After that, we need to check. If the result is odd, we need 2 operations. One to add 1, and the other one is to divide by 2. So if bit is odd, then we will increment our steps by 2 and set the carry. Else, we will increment the steps by 1. Here we need, here a number is odd. We need 2 operation, add 1 and divide by 2 while the else is even. We need one operation, which is divide by 2. And if there is a carry left, we need to add an extra step, which is to return the steps plus carry. This is in case we have carry after completing the loop. Let's run it to make this error-free. Let's submit it. And in terms of complexity, this algorithm scan the binary string only once, so the time complexity is linear, O of n, where n is the length of the string. And for the space complexity, it uses only a few extra variables, so the space complexity is constant, O of 1. This approach avoids large integer entirely and turn the problem into a clean bit level simulation. If this explanation helped you, don't forget to like and subscribe, and I'll see you in next problem. Bye.